Welcome to the strange, theoretical world of white holes. Mathematically, a white hole is essentially the time-reverse solution of a black hole within Einstein's general relativity. Imagine running the film of a black hole swallowing matter backward. Instead of falling in, everything bursts out. A white hole would have anti-event horizon. You couldn't cross it from the outside, but anything inside would be violently expelled. It sounds fascinating, but there's a major issue. Unlike black holes, which form naturally from collapsing stars, we know of no physical process that could create a white hole. They would seemingly have to have been present since the very beginning of time, spitting out matter. Furthermore, they seem thermodynamically unstable, always decreasing entropy by organizing matter to shoot it out, contradicting the usual flow of things in the universe. Because of this, most physicists consider white holes to be purely mathematical curiosities. However, their explosive nature led some to wonder, could our own universe, originating in the Big Bang, be the inside of a giant white hole? The idea seems superficially appealing. Our universe did emerge from a hot, dense state, spewing out matter and energy as it expanded. But this hypothesis runs into significant problems when compared to detailed observations. The standard Big Bang model, especially when incorporating cosmic inflation, explains the incredible smoothness and uniformity of our universe on large scales extremely well. It's not clear that a simple white hole solution would naturally produce such uniformity. Also, the universe as a white hole idea doesn't fundamentally solve the origin question. It just pushes it back to, where did the white hole singularity come from? For these reasons, while an intriguing thought experiment, the idea that our universe is a white hole isn't supported by evidence and doesn't fit our cosmological data as well as the standard model. This brings us back to the heart of both black holes and white holes in theory, the singularity. We keep hearing this term, often associated with infinity. What does that infinity actually mean? In general relativity, a singularity is where calculations yield infinite values for things like density or space-time curvature. But it's crucial to understand this infinity primarily signals a breakdown of the theory itself. It's like punching divide by zero into a calculator. You get an error message, not a truly meaningful infinite number. The singularity is physics telling us, warning, general relativity is no longer sufficient here. You need a new theory, likely quantum gravity, to understand what's truly happening. It doesn't necessarily mean a literal point of infinite density exists in reality. So what could this singularity, or rather the underlying physical reality it represents, actually do? Could it create new matter? Could it just break physics? The singularity isn't thought of as a continuous factory churning out matter. In the Big Bang model, the initial state was one of incredibly high energy density. As the universe expanded and cooled from that state, this energy converted into particles according to known physical laws, like Einstein's E equals mc squared. So, particle creation happened because of the conditions near the beginning, driven by the initial energy, not conjured continuously from the singularity itself. As for breaking physics, the singularity is the point where our current physics breaks down. But the goal of physics is to find the deeper, more complete laws, the rules of quantum gravity, that resolve this breakdown and provide a consistent description. So rather than being a source of arbitrary magic or random physics violations, the region near a singularity is likely where the ultimate unified laws of nature are in full effect. These laws might seem strange to us, but they would form a coherent, self-consistent framework. It's not about breaking physics, but about finding the true physics governing these extremes. In the end, white holes remain ghosts in the mathematics of relativity, fascinating but likely unreal. Our universe's beginning shares some superficial resemblance, but is better explained by the standard Big Bang. And the infinity's haunting singularities are best understood not as literal endlessness, but as signposts pointing towards a deeper quantum understanding of gravity, space, and time waiting to be discovered. Let me know your thoughts in the comments below. Subscribe for more explorations into science and philosophy. Thanks for watching, and see you in the next one.